You've completed Gaussian or Gauss-Jordan elimination, and now you need to interpret the result. No worries, for both processes, there are three potential outcomes that can be identified the same way. Your outcome will either have one unique solution, an infinite number of solutions, or no solutions. The way we identify the outcome is based on the pivots within the final result of the elimination process. Recall, the pivot is the first non-zero entry in a given row from left to right. So for all three of the scenarios, here are all the pivots. A column that contains a pivot is called a pivot column. All of these columns are considered pivot columns since they contain a pivot. Now let's look at the pivot columns for the three scenarios. In our top example, every column on the left-hand side is a pivot column, while the right-hand column is not a pivot column. When this happens, our system of equations has exactly one unique solution. For the second scenario, there is one or more columns on the left-hand side that are not pivot columns, while the right-hand column is still not a pivot column. When this happens, our system of equations has an infinite number of solutions. For the final scenario, if the right-hand column is a pivot column, which happens when the left side of the row is all zeros, and the value on the right column is not a zero, basically when this happens we call our system of equations inconsistent since it has no solutions. There is no combination of values for our variables that satisfies our system of equations. Now that we talked about how to identify the number of solutions for a given system of equations, let's talk about an example for each scenario.